Hello, I welcome you all to your own channel MSK Learning. Now in this video we are going to discuss about the simple stress and strain. Right. So it's very basic class and very fundamental. That just you can say we are going to introduce about the stress and strain. Right. So what is a stress and what is a strain actually? So you suppose you have any material is there, means any object is there. Right. So whenever the object is subjected to the load, what will happen? Because of that load, the body get deforms. That deformation we call it as that the dimension may change. Right. So maybe the length or means the dimension can increase or can decrease. It depends on the nature of the load, means with what type of load you are applying. Suppose you have one object is like this. Is it or not? That this is the load. This is the object. So this object is having certain dimension, that is this is the length, and let's say this is the width, right? That is the P. So imagine that you are applying the load that is of pulling in nature, means you are applying the tensile load, right? So when you apply the load, then what will happen to their dimensions? That the length will increase and the width will be decrease. It means that because of that applied load, the body get deformed, right? And at the same time, due to the cohesion between the molecule, the body resists these deformations, right? So the resistance by which the material of the body opposes the deformation is known as the strength of material. So the subject actually we are learning, the subject name is a strength of material. So what is the strength of material, you can define now onwards. That if anyone will ask you that why you are studying this subject stress of strength of material, right? So this subject is common for mechanical engineering and civil engineering, right? So in mechanical engineering you have to design so many machine component. As a civil engineer you have to design so many structure, right? So for that structure or for machine component you will select certain material, is it or not? So that it means that when you design that component is subjected to certain amount of load, and because of that load the deformation will takes place, is it or not? So you need to know that whatever the material you are going to select, what is the capacity, okay, and what is their capability to resist, how much load that material can resist, right? And that analysis we call it as a strength of material, right? So that is strength of material. Significance I think you understood, right? Means what? That it is the capacity or the tendency of a material by which the material is resisting the deformation of a body, right, because of the applied load, right? So the strength of material, simply you can say the resistance by which material of the body opposes the deformation, right? Opposes the deformation, okay, is known as what? Is known as strength of material. That in short you can say SOM, and somewhere we call it as a MOS also, that is mechanics of solid, right? So see here that whenever the body is subjected to the load, that load we are applying within certain limit, that certain limit we call it as a elastic limit, right? Or that properties we call it as elasticity. That elasticity and plasticity we will discuss later on, right? So first of all we understood that why we are studying the subject strength of material. Why? Because as a design engineer, whenever you will select any material, you should have an idea that that particular material, how much load it can sustain, right? Or up to what limit it can resist the deformation, right? Now so this is the significance or beauty of the subject. So first of all we'll begin where is that? Yes. So we begin the topic and we'll move to the first things that we try to learn. What is the stress? So many time you studied, means you heard this topic is stress. Stress, if I say the general language, that stress is what? That suppose you have a exam 2 days later, right? After 2 days you have a exam. Then what will happen? That you have a lot of stresses if you don't prepare well. Why? Because what type of question will come, whether I can pass or not, right? So how this stress is came? That stress is nothing but the tension, and that tension is come means that will play because of the applied load, right? So if you come analogy, do the analogy with your day by day practice. Means I told you that suppose you have an exam after 2 days, right, and you are not prepared, then what will happen? You have a load of what? Load of passing the exam, right? So that type of that stress is nothing but it's a load per unit area, right? So you can say the stress is what? The force of resistance per unit area offered by a body against deformation is known as the stress. So first of all, basic things we will discuss, that whenever you say stress we are denoting by letter sigma. This is the sigma, right? And the unit for stress is nothing but, in SI system we call it as a Newton per meter square, or somewhere we call it also as a Pascal. Why? Because 1 Pascal is equal to 1 Newton per meter square. When you study the fluid mechanics subject, there you come to know Pascals. Also you already know the relation from the thermodynamics also, right? So first of all you can say that what is a stress. So in simply you can say the stress is nothing but the force per unit area, or if I define in a beautiful way, you can say the force of resistance, the force of resistance per unit area offered by a body against deformation. Deformation means what? That whenever the body is subjected to load, the dimension has changed. Deformation is known as stress, right? So the force of resistance per unit area offered by a body against deformation is known as stress. Mathematically you can express the stress as sigma is the symbol for stress. Sigma is equal to load by area, right? That is load by area, or you can say like this, that is P by A. So this is your mathematical equation or relation for stress, right? So where that sigma, you can say right now, you can say sigma is the simply stress, right, or intensity of stress also you can say, or intensity of stress, right? Intensity of stress, right? Where P is what? Load applied, that you can say load applied, right? Load applied. And A is what? A is your cross sectional area, right? So this is what you have a stress. Now we will see another term, that is strain. So strain is what? That whenever a body is subjected to the external force, right, there is some changes in dimension. It means, as you know, that whenever the body is subjected to the load, the body get deformed, right? The deformation is nothing but your, that is changes in dimensions, right? So changes in dimension, maybe it can increase or it can decrease. It depends on the nature of load applied, what type of load you are applying. If you will pull the body, right, then what will happen? The length will increase. If you push, the length will decrease, right? So next topic you can write, that is your strain, right? So write down very fast that this is the strain. right? Strain we are denoting by small letter e, small e, right? Strain. So strain is what? Simply you can say change in length to the original length, right? Or you can define when a body is subjected to some external force, right? Some external force, there is some change in dimension, there is some change in dimension, that we call it as a deformation. There is some change in dimension, right? There is some change in dimension. So you can say the ratio of change of dimension, right, to the original dimension, is known as what? Strain. Okay, when a body is subjected to some external force, there is some change in dimension. The ratio of change of dimension to the original dimension, we call it as a strain, right? Now I'll show you with some diagram. Let's say one bar is there, right? Let's say one bar element is there whose initial length, means the original length of this bar, is L, right? And the lateral dimension, this is the longitudinal dimension L. If you want to see, the lateral dimension is nothing but the, let's say this is the B, right? This is the B, that is width. And then imagine that you are applying the load, which is the pulling in nature. You can apply the push, you can push the body also. So let's say I am applying the pull, right? That is of having magnitude is P, equal and opposite force along the longitudinal axis. What will happen? Actually, when you pull this body from both sides, the length will increase. If you observe very carefully that at the time of increasing the length, the width is decreasing. So two things is happen at a time, right? So when the length is increasing, the width is decreasing. Means as you are applying the load, load you are applying along the axis, longitudinal axis. So the longitudinal dimension is increasing, but the lateral dimension is decreasing. Or you can say the dimensions across the right angle to the axis of the load applied is decreasing. It means that there is a two straining, that is longitudinal dimension is increasing and lateral dimension is decreasing. So if I show you with this different color of pen, so this is what the shape you will get. This will happen, is it or not? So you see very carefully that this lateral dimension is decreased, this much of length is decreased, this much of length is decreased, but that longitudinal dimension is increased by this amount. We can call it as a delta L, right? Delta L. But the lateral dimension is decreased by an amount of, you can say, delta B, right? So this lateral amount dimension is decreased by an amount of, let's say this is the delta B, right? I hope it is visible. This is delta B, right now. So now if I define that as per the definition, the ratio of change of dimension to the original dimension is known as the strain. So how much changes you got? That this much along the longitudinal axis, and along the lateral axis it is delta B, or you can say along the right angle to the action of applied load, right? That, so the strain we are denoting by letter small e. So you can see the strain E is equal to what? E is equal to change in length. Mathematically you can say change in length to the original length, right? So E is equal to, further you can say, delta L by original length, right? Delta L by L, right? So strain is of how many type? There are the strain, maybe the tensile strain, compressive strain, right? Volumetric strain and the shear strain, right? So now one by one I'll tell you that types of strain. So here you can write strain, right? Strain, and then here itself you can classify them. Let's say this is the tensile strain, right? The second one is the compressive strain, third one is the you have a volumetric strain, right? And finally the fourth one is the shear strain, is your shear strain, right? So four types of strain we have: tensile, compressive, volumetric and shear strain. Tensile means what? That when you pull the body and then because of that pulling there is a change, means increase in length, right? And when you push the body, because of the pushing there is a decrease in length, right? So tensile strain, you can say that changes in increase in length to the original length of the body is the tensile strain. Compressive strain is what? Decrease in length to the original length is the compressive strain. Volumetric is what? Change in volume to the original volume. So here I am I can write that, you may make a note like this only, that is tensile strain is what? Increase in length to the original length, right? To the original length. This is what you can say, that is decrease in length, right? So you can write decrease in length to the original length, okay? To the original length. Volumetric means what? That volumetric you can define here, that is change in volume to the original volume, right? So this is what you have a volumetric strain. Shear strain we will discuss later on, right? So now then you can see here, just wait, I'll put it here. So you can make a point about the shear strain. The strain produced by shear stress is known as the shear strain. So you can say the strain produced by shear stress, shear stress you are denoting by tau, right? By shear stress is known as what? Is known as shear strain, and your shear strain is denoted by phi. So shear strain is denotion by phi. That is what the change in the strain produced by the shear stress is known as the shear strain, right? Now we will see that we discuss the stress, strain and types of strain. Right now we have a types of stress. So you can make a subheading that types of stress, right? This is your types of stress, right? So types of stresses means what? That maybe the stress will be the tensile stress, compressive stress and the shear stress, right? So you can say here that first you will see the tensile stress. So tensile stress means what? Whenever the body is subjected to the pull and per unit area, that is known as the tensile stress. So the stress induced in a body when subjected to two equal and opposite pulls, right? So simply you can say the stress induced in a body when subjected to two equal and opposite pull, right, pulls as a result of increase in length. So you can say how the tensile stress, let's say this is one bar element is there, right, of having length is L, let's move, right, of having length is L, and you are applying the two equal and opposite pull. This is the pulling in nature, right? So what will happen? Because of this pull, the length will increase, and the same time the lateral dimension will decrease, right? So this much of length is increase. That is, you can say, the tensile stress. So tensile stress is what? That you can write here mathematical equation that tensile stress is equal to pull by area. Pull means load, tensile load you can say, right, by area, that is P by A. If you see, the magnitude of the tensile stress is positive. Why? Because the length is increasing. Next you have a compressive. Similarly you can say when the stress induced in a body when subjected to two equal and opposite push, right? So here you can write, that is, the next topic is compressive stress, that compressive stress, right? So compressive stress means what? The stress induced in a body when subjected to two equal and opposite push, right, push, as a result of which decreasing length, right? And then the stress induced, we call it as a compressive stress. So what will happen in compressive stress? This is, you are pushing the body, this is P, this is P. So when you push, the longitudinal dimension will decrease but the lateral will increase. So the new shape, that this is the what we get. It means that this much of lateral dimension is increased by an amount of delta B, and this much of length is decreased along the longitudinal, right? So as the length is decreasing, right, so compressive stress you say that is the negative in nature. You don't think so that I show you that is lateral dimension is decreasing. So we are not talking about the dimension which is changes right angle to the applied load, right? We are only discussing that what will be to the along the axis of the length, right? Why? Because load is applying along the axis. If you apply the load along the lateral dimension, right, then what will happen? In this case, the lateral dimension will decrease but the longitudinal will increase, right? Now, so that is what you can say here. This is the magnitude of the compressive stress will be the negative, that compressive stress is equal to what? Push by area, right? Push by area, that is load by pull, compressive load by area you can say, and the magnitude is negative, right? Now, so this is how you can see the stresses. One more stress is there, which is your shear stress, right? So shear stress is what? That shear force per unit area. You can say the stress induced in a body when subjected to two equal and opposite force which are acting tangentially, right? So tangentially means what? That suppose, well, we'll show you that. First you can say, make a subheading, that is shear stress, right? Shear stress, we are denoting the letter, we call it as a tau, right? So shear stress is what? When a body is, the stress induced in a body when it is subjected to two equal and opposite forces which are acting tangentially across the resisting section. So tangentially across the resisting section means one section is like this, one section is like this, and another section is like this, the another section is like this, right? The another section is like this. Let's say these two sections are joined by a rivet, right? This is the rivet joint is there, and this is the rivet joint is there, right? So this you can provide the hatching, right? So what is that? This section is applying one load of having magnitude is P, and this section is also applying one load of having P, that equal and opposite but tangential. So these two are tangentially, right? This section and these two section are tangentially, right? Now, so what, because of that tangential force, that whatever the stress will induce, that stress we call it as a shear stress, right? So you can write that the stress induced in a body when subjected to two equal and opposite tangential force, right? Two equal and opposite forces across the forces acting tangentially, right? Now across the resisting section, is called shear stress, right? As a result of which the body tends to shear off across the resisting section is known as the shear stress. So one resisting force, this and this, right? So the stress is induced into this section, right? So here whatever the stress is induced, we call it as a resistance, shear stress. So shear stress we are denoting the tau. So you can say the tangential force, right, by resisting area, right? Unit will be same, Newton per meter square. There is no changed. Okay, now then we will see one term, that is the elasticity. So elasticity is what? The property by which the body can regain its original shape and size. Suppose you have a rubber band is there, right? What you do, that you are pulling the rubber band. Suppose the rubber band is there. When you pull the rubber band, the length of the rubber band is increased, right? But you find that the thickness is decreasing. So you are pulling it unto a certain limit. Certain limit is, we call it as elastic limit. And when you remove the load, you find that the rubber band come back to the original shape and size. That property we call it as a elastic properties, right? And the process we call it as the elasticity. So elasticity is what? It is a property by which the body can regain its original shape and size. So simply you can write elasticity, right? Elasticity, elastic in nature, you know, right? The property by which body can regain its original shape and size, is known as the elasticity, right? So that rubber band example, you pull the rubber band and then leave it come back to the original shape and size. That properties we call it as a elastic properties, right? Next you have a Hooke's law. That's Hooke's law you already studied in your school, right? That in 10th class, in 9th class, in 11th class, right? Now Hooke's law is what? It states that stress is proportional to strain where within elastic limit, right? Within elastic limit means what? That up to which the body can regain its original shape and size. Up to that limit the stress will be proportional to strain. So mathematically, if I write this statement, then you can say sigma stress is proportional to strain. When you remove this proportionality, we will use one constant. That constant we call it as a elastic moduli, right? Sigma is equal to capital E into E. This is your Hooke's law, right? This is your Hooke's law, where sigma, you know, that is a stress or intensity of a stress, E is the strain, right? And capital E is the modulus of elasticity or elastic moduli, you can say, right? Modulus of elasticity, modulus of elasticity. That is also known as the Young's modulus, right? That is also known as the Young's modulus. Now we are going to see the elastic constant, right? So there are the certain elastic constant. Before that, we will, we can see the some elastic constant. That first you can say the modulus of elasticity, modulus of elasticity, right? So modulus of elasticity is also known as the Young's modulus, right? Is also known as the Young's modulus, and we are denoting this by capital E, right? So Young's modulus or modulus of elasticity, E is equal to stress by strain, right? This is the stress by strain. Unit is what? Newton per meter square. That Young's modulus or modulus of elasticity will signifies the properties of a material, right? Means how much stress the material can sustain. Next you have a modulus of rigidity, right? Next you can say the modulus of rigidity, right? Modulus of rigidity you can denote it by capital C, G or capital N. I'll show you the G. So modulus of rigidity, G is equal to shear stress by shear strain, right? That is, you can say tau by phi. Its unit is also Newton per meter square, right? The unit will be same, Newton per meter. Why? Because strain is no unit, tau is the Newton per meter square. Strain is a dimensionless unit, right? Now dimensionless parameter. Next we will see the factor of safety. Factor of safety is very important factor while you study the machine design subject, right? Why? Because when you design any machine component, that time you have to verify your designing whether the design is safe or not. So the two stresses we have to discuss, that permissible stresses and ultimate stresses, right? So that factor of safety. So factor of safety, sometime we will denote, in short we are writing F dot F. So factor of safety is what? That you can say ultimate stress by permissible, right? By permissible. Permissible is also known as the working stress, or sometimes we call it as a design stress, right? Permissible or working stress, right? So this is the factor of ultimate stress is what? That whenever you select the material, you have to conduct the test. The test we are conducting on UTM machine, that universal testing machine. by which you come to know that what is the limiting value of a material, right? Suppose that limiting value of a material is 50 kilonewton, so that is the ultimate stress, means up to 50 kilonewton the material can sustain the load, right? And that for safe designing, you always remember that this permissible stress should always less than the ultimate stress. So make a point that for safe design, either you are designing for structural engineering or for your machine component, right? For safe designing, right? Now for safe designing, that permissible or working stress is less than the ultimate stress. It means that ultimate stress should always dominating over the permissible stress. If your permissible stress is dominating over the ultimate stress, then the design is failure. You have to redesign the machine component. So this is all about the today class. In next video, we will discuss the Poisson ratio. We'll see the relation between the lateral and longitudinal strain, right? We solve some problem, elongation in a bar, and so many things. So thank you.